So hello everyone. So last lecture we have covered adsorption and now we will start colloidal solutions, colloids. Okay, good evening Anika and Abhay. So let us write it. Colloidal state of matter. Okay, it's not visible. बेटा 1 मिनट वेट करना है. Okay. Yes. Yes, beta. Is it visible to you? I think now it's okay. कोलॉइडल स्टेट ऑफ मैटर। तो पहली जो क्लासिफिकेशन है दैट इज डन बाय थॉमस। क्लियर? थॉमस ग्राम ने सबसे जो उनको दो कैटेगरी में क्लासिफाई किया, वो क्या थे? एक को बोला उसने और दूसरे को बोल दिया उसने क्लोइड्स। एक को क्या बोला? क्रिस्टलॉइड्स, और दूसरे को क्या बोला? क्लोइड्स। ठीक है ना? अब ये क्रिस्टलॉइड्स और क्लोइड्स में उसने कैसे डिफरेंशिएट किया? यू नो थॉमस ग्राम्स लॉ ऑफ डिफ्यूजन, उसने रेट ऑफ डिफ्यूजन जो है ना स्टडी किए, सब्सटेंसेस के रेट ऑफ डिफ्यूजन। ठीक है? एक कैटेगरी में उसने रखा जैसे शुगर है, यूरिया है, which are readily soluble and they are crystalline। क्या soluble थे, they are dissolved easily, और क्या थे वो? crystalline। तो ये जो थे they pass through the animal membrane और parchment paper readily, वो उसके थ्रू इजिली पास हो रहे थे, डिफ्यूज हो रहे थे थ्रू इट, को बोल दिया क्रिस्टलोइड्स। इवन NaCl। और दूसरे टाइप लिए उसने ग्लू लाइक, जैसे ग्लू स्टार्च है, ठीक है, जो कि थे लेस सॉल्युबल। इवन सिलिसिक एसिड है, ठीक है, इनको उसने बोला दे आर यू नो नॉट डिसॉल्व्ड और दे आर लेस डिसॉल्व्ड, और वी कैन से लेस सॉल्युबल। और ये क्या थे? नॉन क्रिस्टलाइन। एक क्रिस्टलाइन जो कि डिसॉल्व हो रहे थे इजिली और पास हो रहे थे थ्रू द पार्चमेंट पेपर और एनिमल मेम्ब्रेन रेडिली इजिली, और दूसरी कैटेगरी थी जैसे ग्लू है, ठीक है, गम, स्टार्च, ठीक है, ऐसे सब्सटेंस को उसने कैटेगराइज किया कि ये नॉन क्रिस्टलाइन है, वो तो थे ही, और ये दे आर लेस सॉल्युबल। तो उसके हिसाब से उसने बोला कि इवन इस कैटेगरी में जेलेटिन भी आ जाएगा, इवन एल्बुमिन भी आ जाएगा, ठीक है, इन सब को उसने क्रिस्टलॉइड, सॉरी, ठीक है, तो इन कैटेगरी को उसने क्लोइड्स और क्रिस्टलॉइड दिया। बट क्लासिफिकेशन थी ये थोड़े बाद फेल हो गई। फेल हुई कि देखा गया कि NaCl अगर वाटर होता है, यू नो इट इज हाईली सॉल्युबल, तो एट दैट टाइम इट एक्ट एज क्रिस्टलॉइड्स। बट वही NaCl जब बेंजीन में होता है दैट इज लेस सॉल्युबल, सो इट बिहेव्स लाइक क्लोराइड। The same substance in different solvent behave as colloids or crystalloids. So ये classification जो है has no role to play while selecting the substance. जैसे मैंने बोला कि NaCl और पूछ लिया कि NaCl is crystalloid or colloid. So your answer should be we don't know. Question is wrong. Question is wrong. I have to mention the solvent. I have to mention the in which NaCl is present. If NaCl in water, that NaCl is crystalloid, because in water NaCl is highly soluble, and you know why? because NaCl is ionic compound, water is polar, like dissolves like. That's why it behaves as crystalloid. But same NaCl in benzene, their nature is entirely different. Non-polar. NaCl is highly polar ionic compound. That's why it is in what benzene, and that's why it behaves as colloid. So colloid is not a substance, it is a state of a substance. What I said? Colloid is not a single substance. We cannot categorize a substance colloid. It is the state of a substance, and it depends upon the size of the particle. That's it. It depends on the size of the particle. Now, what is the size? So, on the basis of the size of the particle, they are classified into three categories. First is true solution. Second is suspension. Say, I didn't mention this one. True solution, suspension. And in between these two is the third category, that is called colloid. First is true solution, and extreme is, these are two extremes, true solution and suspension. And in between these two categories is colloid. So colloid has some properties of true solution, some properties of suspension. That's it. Okay. So let's write the classification. So exact classification, this crystalloid and colloid is not the true classification of the components or substances. That's why it was failed. Okay. Now let us, first is true solution, second is colloidal solution, and third is suspension. These are the three categories. So in true solution, size of the particle is less than 1 nanometer, or we can write it as less than 10 angstrom, or we can write it as 10 raised per minus 9 meter, because nanometer means 10 raised per minus 9 meter. Now colloidal solution, in colloidal solution, size of the particle is I will write afterwards. First I write for suspension. So in suspension, size of particle is greater than 1000 nanometer, or we can say greater than, yes, 10,000 angstrom, or we can write greater than 10 raised per how many? Minus 6 nanometer, sorry, meter. Got it? 1000 nanometer. Now tell me, what is the size of the particle of colloidal? Yes, it is your time. Just tell me. Yes, beta. What is the size of the particle of colloidal? Fast. Respond fast, beta. I am mentioning the number. So you should mention the number, beta. Abhay, just mention the number. Yes, it is greater than 10 raised power minus 9 meter and smaller than 10 raised power minus 6. Means it is in between 1 nanometer to, yes, 1 nanometer to 1000 nanometer, or we can say in between 10 angstrom to 10,000 angstrom, or we can write 10 raised power minus 9 meter to 10 raised power minus 6 meter, because if size is less than 10 raised power minus 9 meter, that is true solution. If it is more than 10 raised power minus 6 meter, it is suspension. So in between that is colloidal solution. Okay. Now let us write the difference between these three. So first difference is in front of you, that is the size difference. Now what is the nature? Let us write the different properties. Difference between colloidal solution, true solution and suspension. So tell me, nature of true solution, is it homogeneous or heterogeneous? Yes beta. Yes, tell me. Yes, very good. So true solution is homogeneous. And what about colloidal solution and suspension? Sorry. So keep in mind, suspension, suspension means sorry. Suspension means sand in water. So sand is separated entirely from the water. So it is heterogeneous. True solution is homogeneous, suspension is heterogeneous, and colloidal solution is also heterogeneous. It seems like to the naked colloidal solution seems like homogeneous, but in actual it is heterogeneous. Okay, if we see under microscope. Okay, then particle size we have already discussed. Particle size less than 1 nanometer, in between 1 nanometer to 1000 nanometer, greater than 1000 nanometer. Okay, is it visible? Very good. What about filterability? Yes beta. True solution particle size is very less. It pass through filter paper as well as animal membrane. It pass through ordinary paper as well as animal membrane. Okay. In colloidal solution, it pass through, its size is intermediate, so it pass through ordinary filter paper but yes, but not through animal membrane. And suspension, you know, size of particle is very large, so it can neither pass through ordinary filter paper nor through animal membrane. Okay, see, nature homogeneous and true solution homogeneous, colloidal and suspension both are heterogeneous. Particle size less than 1 nanometer, in between 1 nanometer to 1000 nanometer, suspension greater than 1000 nanometer. Filtrability, so true solution pass through both, you know, very less, okay, less than 1 nanometer. That's why it can pass animal membrane as well as ordinary filter paper. You know, in ordinary filter paper, pore size is large, so large particle can pass through, so true solution can pass through easily. But in animal membrane, particle size is less, pore size is less, so colloidal particle, which is size is intermediate, cannot pass through it. But you know, animal membrane may say true solution particle can easily pass because size is very less. In case of colloidal solution, size is in between this, so it can pass through ordinary filter paper but cannot pass through animal membrane. And it, you know, size is very large, more than 1000 nanometer. That's why it cannot pass through even in ordinary filter paper. Okay. Next is settling. So tell me, true solution particle, are they settle? Settle means they settle down, and there is an effect of gravity. Is there any effect of gravity on the true solution particles? If we dissolve sugar in water and we wait for 10 minutes, 20 minutes, 30 minutes, or even 10 years, and we close the cap. Reason being, if we open the cap, water will evaporate and sugar will stay inside. Okay, settle down. But if water is there and we dissolve the sugar, settle होगी वो कभी? Yes बेटा, tell me, कभी sugar settle होगी? Yes, so it will not settle. So it will not do not settle. Colloidal solution do not settle. Even colloidal solution, blood, mud, these are the example of colloidal solution. They never settle down. But you know, if we dissolve sand particles in water, on standing it settle down, so settle on standing. Settle on standing, right? Okay. Now next is visibility. Visibility. Tell me, true solution particle, as they are very small, they are not seen naked eyes or even under ultra microscope. Particles are so small that we cannot see them by naked eyes or even under microscope. So, true solution particles are invisible, but colloidal solution particles are visible under ultra by yes beta, are you able to see it? Say, in case of diffusion, true solution particles are very small, so they can diffuse quickly. But as size grows, diffusion becomes slow because its movement becomes slow as the size becomes large. That's why colloidal solution particle diffuse slowly, and suspension they not diffuse at all. But if we talk about appearance, true solution particles are completely transparent. Colloidal solution particles, they are translucent. They are on the other side. Okay, so that's all for the day. Sorry, today there's a network problem. Okay, so we'll continue class tomorrow at 8 p.m. Okay, bye bye beta.